Okay, welcome to Cloud Training for Enthusiasts. My name is Patrick Osotomi Agbogun. Today is going to be a fast-paced class. And being that we have already used about 20 minutes discussing about the future of the cloud and the future of IT. But now we're going to be talking about cloud training, compute virtualization. So the word virtualization is what we are going to focus on. So because most of us have heard of VMware, virtual machine, hypervisor, EC2, cloud compute. So some of us have even spin up. In our last class, we spin up EC2 instance, right? We spin up EC2 instance, and it was interesting configuring it. But if you don't understand cloud computing or virtualization or virtual machine, it will be difficult for you to know, because virtualization is what led to cloud. In fact, it's infrastructure that made cloud possible. Without virtualization, there's nothing like cloud. So it was even the same virtualization that led to Dockerization, also known as containerization. This is where we are now. We are in containerization now, right? It's under this containerization that orchestration was built on. But currently we are still in containerization. We've not left containerization. So we are now in containerization. Under containerization, that's what we have orchestration. So fear of Dockerization is under here. Fear of orchestration, this is where Kubernetes came out from. Then we have Kubernetes is not the only orchestration tool we have, but it's just that it's very popular. Maybe you've heard of Docker Swarm. Now we now have Rosa. Rosa, yes. What is the meaning of Rosa is Red Hat, Open Swarm architecture, something like that. Have you heard of Open Swarm?
No, I've only heard of Kubernetes and Docker Swarm.
Okay. We have
orchestration.
Just that Rosa added Dockerization, orchestration, and virtualization together.
Wow.
So meaning if you are using Rosa, you don't need to think about the underlying auto-scaling infrastructure. So it will automatically scale up and scale down. It will also manage, Rosa also provides DevOps for you. So meaning the developer will just focus on doing the code. Meaning the code is ready, you just commit it to that branch. What happens is that Rosa will automatically pick it from the source code. We'll look out for the application type. It will by itself write the Docker file for it and Dockerize it.
Yeah.
After Dockerizing it, you push it to ECRO or registry. Then from your registry, you deploy to Kubernetes.
Yes.
It will do everything for you, including the network infrastructure, the everything. So you see where the thing is going to. Rosa is fantastic. It just came out recently by Red Hat, which is also a Linux company. So you see, but everything you are talking about here lies here. Without this virtualization, all this wouldn't have been possible. In fact, the cloud we are even learning now wouldn't have been possible. Now, what is virtualization? I'm going to please take note of this class. Please take note, be attentive, because if you miss it here, it'll be difficult. Now, let me explain it in a layman language. Normally, you are supposed to have a machine that serves application to the people, known as server, right? No, this is server now. And server has almost basic infrastructure that your normal laptop should have, right? It will have the memory, to have underlying network, because it's true the network is going to be serving to people. It will have compute, which is known as processor, right? It will have the operating system, OS. So better put, let me just draw something like this. So it will have all this layer in it. The network, because you have to set up the network, apart from the power, understand power now and everything. You have to plug it to power now, right? So let me put power here so that to make it look as if make it look electronics. Fine, everything is built on its electronics. Let me just put power here. I mean, it must be running, right? Okay, now it will have its power. Let's put power here. Although sometimes we don't always put power because power is another deeper aspect of it. Let's remove this power. Because if I'm to talk about power, not this aspect of it, because it's through this power you're talking about fault tolerance. Let me put power. But this is the first time I'm going to be adding power to my class, because our modern day server have two power input, two power source. Imagine your laptop have two power. Your regular laptop have like a battery, right? It has power cable coming into it, right? But most server in data center has 2 or 3 powers. So meaning you connect 3 power plug to one server. So in case one power goes off, the other one takes over. We call it redundancy. We also call it fault tolerance. And those power are not coming from the same supply. They are coming from different supply. If you are using 3 power supply, 3 power units, so leg 1 will come from, and that leg 1 is going to come from another transformer. While leg 2 is going to come from another transformer. So that in case the 2 transformers, they are going to come from different power grid. Just in case one goes off, the other one takes over. Just for provide high redundancy. Okay, now let's call that one power. Now, another power aspect that it will have is the network, Network, because you have to set up your network where the server is going to be relying on. This is a typical server. Then the next thing you have to, like normal system, just look at your normal laptop. Which other things your laptop have? You have hard drive, Abi. Let's put processor, compute power. Then the next thing, what's the next thing? Storage, right?
Yeah, storage.
Then after storage, this storage includes both the RAM, ROM, and everything. Then the next thing you now put, after you set up your system, you now set up your underlying architecture,
infrastructure,
which is mostly must have its own regular machine language, normal machine ware, you understand me? Like normal system ware. We call it system ware. It's not OS. And after the system ware, before you now have your OS.
Okay, is it called kernel?
You can call it kernel.
Okay.
Kernel, you can call it system ware. Kernel. It's C-A-R-O-N, sorry. C-A-R-O-N-E-L. So it's just a basic tool that will enable this aspect of this computer to communicate on the machine level. So they'll be communicating within themselves. Okay. So, but they will need some system software. This is also part of system software, though. There's another system software called OS. You understand me? This OS will come with drivers, because this OS is the one that will be communicating between you and the user, right? But there are so many underlying infrastructure that you have here. Then these 2 parts This is the OS. Well, before the OS we install, we have to first of all put some system software called drivers, drivers and co. All those ones are not, but we can combine these two together as one. Let's move this one. Let's not confuse it, because most OS, you understand me? For OS to be installed, it comes with its own driver. Then after that, you now get your application that you want to run, maybe Microsoft Word. So this is just a high-level diagram of a server. This is the server, right? So if this server is, let's assume this server is 2 terabytes, 2 TB, hard drive, 2 DB hard drive, core, let's say 24 core, but most times servers are heavy. Server is going to be serving a lot of people, right? So it must be fast. So it must be very fast. What is 24 core? Core means number of multiprocessor. Understand me? Then we're talking about the speed of the processor should be like, let's say the capacity of the processor. Please take note of this thing. This is basic computer science, right? That's why this is where my computer science school come to play, right? So the capacity, let's say it has, it's in has, processor capacity is in has. Let's say it has like 32 gigahertz. Let's say it has 23 or 24. Let's just put, let's say 24 gigahertz speed and 2 gig RAM.
Graphics.
The graphics card, sometimes it may have come with graphics card, which is also going to be in call it GUP, Abi. No, graphics processor. Is it GUP? Yes, GUP. Graphic user. Come on. Yeah. So it's going to say the processor is like, let's say, 3 gig, 3 GB graphics card. 3 GB, yes. 3 gigabyte graphics card. And so all these ones are the system. Now, by the time you put all this, your application inside, right? Then you put this application, you now serve the application through the public IP, or through the load balancer. Depends on how you want to serve it. So people will be using the application by the time they log in with that DNS from the network. It's a complex network though, but let me just make it simple. So through DNS, which is known as domain name service, like www, you understand me? Let me put www here. So this is how people serve network, So before you have a server, you have to set up your system, set up your network, your private network, your gateway. After you set it up, then you now install an OS. It could be a Linux OS, Linux server, if it's Linux OS, maybe Ubuntu or Red Hat, or Windows server. You put your Windows here. After you put your Windows, you now put the application you want to serve and expose the service, and through the service, DNS, people start using the server. So imagine if you have 20 applications you want to install, you want to run. So all the system, you can install the 20 applications here. Then you serve them through different DNS, right? But if you notice, if this system wants to be compromised, you notice that because it has one access in, you understand me? People are configuring it from in. What happens if that place is compromised? The whole server goes down, right? And everybody go back to your house. Like when I was saying, server don't shut down. I remember when I was working in the data center, there are some set of customer service that we were working with. Immediately there's a power outage and maybe one of the application goes down. They are always happy, like server go down when they go out. So the infrastructure team will have to be on ground. The data center engineers have to be on ground to make sure that the server does not go ground. You understand? But imagine all of them are just serving just one application. That means every app server is working on one application. This app server can be sometimes remotely configured, but it cannot be shared. So when this visualization came, this is what visualization came to do. Let me continue with this. So visualization came to do this. Instead of after you set up your power, your network, your compute, your storage. No, this is not what visualization came to do. Let me explain like this now. Let me use a new one so that it will not confuse us. That's what I just explained. That this is also known as bare metal. Maybe you've heard of bare metal, right? In case you hear bare metal, this is what they mean, right? Metal, bare metal, meaning physical server, the real server. So when visualization came in, this is what it came to solve. So immediately you configure your server, this server now that we have. Let me take this one, excuse me, Control C and Control V. Remove this. Remove this. Paste it here. Okay. Now, what this is a bare metal, right? It has all the requirements. So what virtualization came to do is that instead of begin to set up your network and everything, it now provided a layer. So this layer called this VMware, also known as hypervisor. It's a system software that enables you to share your server into different units. It's not partitioning. Like this server now is 2 terabytes, right? So when you put this virtualization here, you put the server, you configure the server. Anybody that wants to use the server will not be able to use the server as a complete entity. We now, as it's configuring it, we now have to tell the number of memory and storage that he needs from this main one. For example, now we have let's say we have 2 gig RAM, 2 terabyte. So maybe this server now, this server that is setting up, let me put this configuration here. Let me set it up here, excuse me. I take my time to do this class because this is where if you don't understand this class, it will be difficult for you to even learn Kubernetes and Docker and everything. You wouldn't even know what those things are. If you learn Docker, you just learn it for learning's sake. You may not understand the underlying infrastructure that Docker is built on. Okay, now, for example, this part of this system now, you want to set up, you want to use this server because it has already been hypervised. If you put hypervisor, we'll call it hypervised. Hypervised. An hypervised server is a server that is already running on a VMware. So what happened is that you can now decide to tell the kind of the path you want to use. You understand me? You can now decide to not share these resources. So you can say, okay, this part I want to use, let me use, but you cannot use more than 2 terabytes, right? Because the whole system is 2 terabytes already. You understand? Maybe you can say, okay, let me use 500 gig. It's now, instead of gig, now it's now called GIB. You know why it's GIB? Because it's a virtual aspect of the memory. It's not the real aspect of the memory. You understand me? GIB. Okay. Now you say core. What's the processor you want to use? Maybe you say you want to use, out of this 24 core, you want to use 8 core. 8 core, right? Then what other thing? The capacity, the processor. Because you are using this 8 core, you're going to have its own allocated processor. Maybe it's taken like 4, let's say 8 gigahertz. as processor. Now, what other thing again? The RAM, let's say the RAM now. Let's say it's going to use like, we are input RAM here. Let's say 32 GB. So you now take out of it and you say it, maybe you're taking like 6 gig. 6 GB RAM. So this is what you are setting up. Interestingly, this system you just set up now, that you just pick from this main system, is going to act independently. The network is going to be sitting on, it's going to be independent network. You don't understand? So like this one that it has all the network. So because you've already set this particular portion of it out, so it's going to be an isolated system working on its own with its own network, underlying network and storage. Going to have its own network, storage, which also include RAM, right? Compute power, then which other one again? Mention. Let's just put OS here. There are so many things here. Put OS. Then you now put your application inside. Interestingly, this system will be working on its own. It will also have its own network. Remember I told you it has its own network, right? You can take one virtual machine from this server and you go to another server again and take another virtual machine and put 2 applications in them and spread the load balancer across them. Let's assume that this is another system. Let's assume this is another server from another system. You see, that is the beauty of it. So, Control D. This is another server from another system. You can serve this network out. Why this one will also serve its network out. Then you now bridge them together with a load balancer. Take note of this, because I'm going to be doing load balancer when you hear load balancer. So this server will be serving. Let's assume that we have Microsoft Word here. Our application is Word. This same application is here, Word here, right? Control D. So you can serve these 2 applications that in case this one goes off, this server that is still serving this application, the load will be transferred to this server. When the server comes up, the load will be transferred 50-50 here. Some will go here. So that means if anybody want to connect to this server, maybe through the network, you are connecting to the server, the network can send you to here to use the application here, or send you to use the application here. This thing that is sending, that is giving you the opportunity to choose, that is sharing the load based on what demand, is called a load balancer. So this is called a load balancer. So when you connect to it through the website, so it can either send to this place or send to this place. But either way, so in case this one goes off, this one will take over. In case this one goes off, this one will take over, but they'll be running as a unit. The same way, this system too, you just remove some portion out of it. You just remove this portion out of this server, right? Now you can also create another server again, another VM out of it again with different specification. Another server, let me use the word server. I know it's not called server though, with different specs. But this and this, if you combine it together, it must not be more than this. It must be between, because you are taking out of the main bare metal. So in that case, you can see this virtualization now made this bare metal server to be shared in different portions. So And that portion that you pick is called a VM. It's a virtualized machine. That's why we call the word virtualization. You understand me? It's a VM, meaning it's a virtualized machine. That is a machine that was taken from a whole compute bare metal. That's the meaning of the word VM. Now, you see, that's where VM comes in. Now, also understand one other interesting thing. This is a VM, this is a VM, right? These two are working on this. And you can do this thing through the internet. You don't need to go to the physical server to be sharing it. Because this visualization also provides the network, also support networking. Because the server also support networking, you don't need to go to the server physically before you can create these ones you want to do. You can just log into this server. Because this visualization is already been done, you can automatically then configure your server remotely and take out a server from an existing server. So let me use the word now. Let me use the right word now. You take out a VM from a bare metal. Or let me use the right word. You take out an instance of a server, which is known as a VM. Or let me use the right word. Or take out a virtual machine instance from a server. You not hear the word instance. Maybe some of us have heard the word instance, right? You've heard of the word instance now, right?
Yeah, from EC2 instance.
But apart from EC2, you're going to be hearing the word instance. It's not two-faced, so they're not saying for instance, you understand me? It's just that they are saying an instance is a portion. Like this one now becomes an instance of this bare metal. This is an instance of this bare metal. So consider it to be an orange. You know, when you peel the orange, right? You can take a portion of the orange out. But if you take a portion of the orange, that portion carries everything that is also inside other oranges, right? Other portion, right? All portion of orange, they have juice, they have seed, right? They are wrapped together and they work independently. They are indifferent. Just consider that that's the concept. That's the only analogy I can give, the physical analogy of a server. So this is just going to be a portion of the complete orange. So that this portion of the complete orange that is working on its own independently becomes an instance of this server. So when you hear the word instance, it means that is a virtualized server. So that last class that we launched an instance, we configured it, we put an application called, a web application called Nginx. Nginx is just like a Microsoft Word, just that most times it's used for serve web application. So we installed Nginx and we now saved it and we're able to receive it. You understand? So that thing we're doing, remember when we are configuring it, we pick up the storage, right? We pick up the OS, right? We picked up what? We configured the network, right? You remember now?
Yeah.
We configured all those things. And when we did that, we now launched it and we now logged into it and we now started configuring it again. So that was an instance. So that instance that we are working on was actually picked from a server, a compute instance, a compute bare metal that was in the AWS data center, also known as cloud infrastructure. You understand now? Do you understand now?
Yes, boss.
So let me use this opportunity to also talk about Docker. A Docker is just, it's not really more different from what we just talked about. Because so by the time we start practicing, we just practice instead of talking about Docker again. You understand me? So let's just explain Docker here and explain Kubernetes here. So in our next class tomorrow, we'll practice, right? Is that okay? Or should we just finish this practice? Then tomorrow we'll do Docker. We finish. Well, I cannot finish Docker tomorrow. We cannot even finish VM tomorrow. Which one do you think we should do?
So if we say we take the theory today, can we do the practical for the two of them tomorrow? Is it possible? Can we
finish the practical for the two of them tomorrow? We already done one, but we can begin. Docker is another. It's not something you rush because everything we are building now is on Docker. So if you don't understand Docker, you're on your own.
One step after the other.
You understand? but we can practice both. We can practice VM because there's nothing new in VM. What is new is what I just explained about VM now. This is what makes it a VM. So this hypervisor is two type. We have this one I just explained now is called HPV1. Then we have HPV2.
Sorry, I have a question on this hypervisor side. All right, so there was a time I wanted to install a particular I've forgotten the name of the application, a particular application on my system, and then I couldn't run it. I wanted to use it to run VMs, yes, but I couldn't run it because the hypervisor was not enabled on my system. So I wanted to know. Then I was using an HP. Then I wanted to know if it is possible to, let's say, just as we SSH'd into the instance the other day, I wanted to know, is it possible to be able to create VMs on our system even without having to download every other applications?
Yes. So that's the aspect I'm going to now. That type of VM that you can install on top of an OS is called hypervisor 2.
Okay. So I was too forward then.
Yes.
Sorry.
It's called hypervisor 2. I thought you said you wouldn't be a FICO now. It's not a lie. It doesn't look you. Yeah.
I don't be a FICO. I better go. No money I didn't find.
This one I explained now is called HPV1. You install it on a bare metal so that other things can come on board. But you can actually have an OS running and still install another hypervisor on top. As a matter of fact, that was what people were doing before Docker started coming to play. If you are into security, is what you're going to be doing. Okay, you're going to be using kernel, Kinesis, Linux, virtual machine, because you want to talk to the internet. You don't want the internet to know where you are coming from.
No.
It's the way you have to set up your NAT gateway to translate and pass it through a VPN. Understand? So it will take people that have another higher level to understand how to trace the network. So that one is another thing. In fact, that is the same architecture that cloud is built on. When you hear NAT gateway. So it's just that after you install an operating system, you will now install a virtual machine on top of that operating system. Then if you install another virtual machine on top of that operating system, you know that virtual machine is still going to share on the underlying system infrastructure. Then you cannot put another OS on top of that virtual machine. So like many systems, many IT people already done it. I think I can send one VM virtual machine, VM box. I mean, end of VM box. You've heard of VM box now, owned by Oracle. I'm saying it.
Yeah, virtual box. This was the stuff I was trying to install.
Yes. You can put this virtual box on your. You can put this virtual box on your own system. And
I already have my own.
And run it as if, so it's going to run as if you have another system, a system inside another system. So it's good to virtualize your system and run it. So you can do that. So now let's talk about Docker. the underlying infrastructure that Docker is built upon is on top of, oh God, I hold on, please. The VM is built on top of this, Docker is built on top of VM. Now, let me just, I won't go deep, but because we are going to be talking about Docker, we're going to be practicing Docker. Just that for a Docker to work, after you've installed this VM here, you see, after you install this VM, you've done everything. You cannot install another application. A VM is also another application. It's like a normal application. It's called Docker demo. DAEMON. A Docker demo is a Docker machine engine that allows you to install a containerized machine inside your own system. Let me explain it better here. I think we still have like 20 minutes. I always take my time to do this because if you understand this very well, forget, there's nothing about cloud that you don't know. Everything you are going to be using in cloud, they are built on this. Okay, now, maybe let's recap. We said we have our network. Our network storage, let's assume you have those things here. We have our network, we say network setup. We have our storage, our compute, storage, OS, right? Then our application. If you noticed, the area where the application is going to be residing on is going to be one place. So all the applications are going to be saved and stored here. But Docker says it will be better. Docker is an application though, but it's a virtualized application. Now, instead of putting one application here, I will explain that one in details when we start talking about Docker. But let me just put this. I'm trying my best not to overflog this so that it will not confuse you guys. Okay, now let me put this one. This is an OS. Under this OS, you can put a Docker machine called Docker demo. That does not mean that this Docker demo is not going to stay, it's going to still stay inside this application. Remember I said after OS, the next is application, right? This Docker demo is still going to be under application of your VM. Meaning you can have a Docker running your machine and still have another application running inside that machine, right? A Docker is just another layer of application. Just that the advantage of a Docker is that it's able to create a miniature compute-like application. This is what Docker helps you to do. It will create, this is what, let's assume this is a Docker demo. What he does is that it will enable you to create a miniature kind of application that can house a miniature kind of compute application that can house an application in isolation that will be running on its own. So this is how Docker machine look like in a high-level diagram. So I can still have under Microsoft Word and have my Docker engine. Just that this application that I have that are Docker, that are container, they act as if they are independent VM. They have their own network structure. They have their network, their storage, their operating system. You understand? So this container you are seeing here has the same infrastructure that this VM also have. What does that mean? It means that you can put an application inside and zip it and still make it available for people to use. You see how interesting it is? I'll tell you why Docker became very important. So it will have the same storage. To have, no, you know, it's going to be small storage though. Storage, image, network. and everything, even compute. So image is like an application. It's like the operating system, but it's not really like operating system like that. So, but we can also call image, this image in this context is the application. So meaning this engine, this Docker engine will be managing all this application inside. We're managing how this application communicate with each other. They are going to be having their own port, meaning I can install Microsoft Word or MySQL or Nginx, you understand? I can install, so each of these container, I can decide to install different application inside. Then all these applications will have their own network that is going to be serving. And they will be acting. If you are using them, you will not even know that you're not even connected to a server, that you are connected to a VM, to a Docker container. That is why whenever you see Docker symbol, you always see it like this. Wait, I think I have one here. Hold on. You always see Docker like this, have you? Docker like this. Have you seen, you know, Docker, this is how they do Docker, right? So you always see Docker like this. Because a Docker is just an application, a compute application that has the capacity to create a container, meaning create an enclosed place where application can run. That an enclosed place where that serve on its own, it lives on its own environment. You can put an application inside and run the application from inside, and the application will be running where that kind of application is called Docker. It's called containerization. So that is where Docker came in from. I think this is how far I can flog it without flogging it too much. Do you understand? I can go far. These ones are the one I use for other students. Let me come back here. Do you understand? Any question? But I'm going to go a little deeper now.
Maybe after you go deeper, I have a question.
Go ahead with your question now, so that at least your question may give us more light.
Okay, so yeah, I would love to know. So let's say in app development, I've always been like researching this. What role, like at what point does Docker come in? Now, let's say after the developer was able to build their app, and then just as we deployed an Nginx server the other day, so they built an HTML code that was giving us like some things, and then they also built something for the backend. And then we were now able to move those codes to the Nginx, the port where the Nginx is pointing to. Now, in that case, how does Docker come in place? Like Docker generally, how does it come in place? How is he able to help us build the container, just as you're explaining?
Thank you so much.
I don't know if
I know what you're trying to ask, but let me just, if it's what it means is that, what is the use of Docker container, or what aspects do you need to use Docker, right? In application delivery.
Yeah.
What you're talking about is application delivery. Last class, we set up a VM, right? And we allowed we now set up, after setting up a VM, we automatically install an Nginx inside. We didn't install it as a Docker file. No. We install it as a normal application, just the way we can install Microsoft Word and everything. So inside that Nginx has so many, you have two major aspects. We have the delivery aspect, which is the HTML file. We have the server configuration aspect, which is under the ETCs, Nginx, you understand me? Default config D. So what we did, we configured the config D so that they can explain. That same framework that you saw, just that application that we are delivering the application using the server. We didn't put Nginx inside a container. We can decide to put the application that the developers have built. We can ship it inside that VM, that folder, and expose it. But we may want to make it more highly available. What does that mean? It means that instead of us to just put it inside this application framework of the VM, we can actually spin up a Docker and install Nginx in these containers, maybe 2 or 3 of the containers. Nginx will be inside. Then we will now use this Docker to transfer that file, that application that they built, inside this Nginx. So instead of Nginx running in this server application framework, it will be running inside a framework called Docker demo container. So meaning we can run like 5 versions of that application and expose it to a load balancer. In case one of them goes off, the other one will take over. But all of them, instead of just putting inside a simple application, we're not putting it inside a Docker. That means that's what we call Dockerization. So we need to create a Docker container of the application, create an image of the framework, put the application inside the Docker container, and serve the Docker container serve the application through the Docker container via a network. So we can decide to bind this network to this VM by exposing a particular port. So we bind this container network to this VM. Then this VM now will now have its own network that will be exposed. So you are exposing the VM network, but through a port, maybe assuming that this is port 22, port 50 or port 8080. That's where the port of the container is running. So that means anybody try to access this VM at port 8080, it will be communicating with this Docker container. So the Nginx will be running, instead of running on that application, will be running inside the container that is managed by Docker. But it's going to be lighter. That is another aspect I'm going to be talking about. That's a deeper aspect I'm going to be talking about. Understand me? It's not going to be as heavy, because running an Nginx application as a normal application under this application framework, not under VM, Nginx, is going to be heavy because there are so many things that it will require for it to run here. I'll explain that later, but let's just understand this. Do you understand this now? You understand your question now. So what you do, you either collect the application in the modern days framework, modern days application development lifecycle. They will not allow you to put the application in a live VM. They will want you to put it inside a container because there are so many other applications, because most times an application does not work on its own. Maybe this could be Nginx. This could be, maybe we have a LAMP application, right? So we can put our Apache here, put our PHP here. You understand me? Which other thing? MariaDB, yeah. Then these are 3 containers. We cannot use network to communicate, to share it together. You understand me? So the 3 will not be working in separate containers. So in case one goes off, well, now this is called
load balanced.
This is what we call microservices. So having an application running on its own and tie into its own database. I'm going to be talking about that's microservices. That's on that topic of its own, but it's the same. We are getting closer. You understand me? So maybe some of us have heard of the word microservice. We have heard of the word Docker, containerization, container orchestration. But the challenge is that when this Docker dies, when this container dies, everything about it dies with it. Nobody knows what is going on unless when you are trying to access this application through this network, you notice that the application is giving you 504 network, that means or not available, or site not available. You know that that Docker container is dead. You quickly go and spin up another Docker container so that it can serve. So this is where Kubernetes now comes in. Kubernetes will help you to check all the network, check everything. And if any container dies, Kubernetes will automatically create another container and replace the one that dies. So that is orchestration. So Kubernetes will be the one to say, okay, 5 version open, 3 version open. That is where the word orchestration comes in. So orchestration, containerization is running an application that can make that can create a framework that an independent program runs on, or independent application is running on. So, but it's not really, it's a demo machine. It's a system software. Docker is not really like a normal application. It's a system application that enables that you just create some small container, and through that container you can decide to put an application inside. And moreover, a container cannot just run unless there's an application you have to put inside. But if it runs and there's no application inside, it's going to be crashing sometimes. And if it's not crashing, it's going to be there, idle, consuming your space. So you have to destroy it. That's where you now run Docker command, Docker PS, Docker application, Docker container,
Docker build,
Docker image list to know the Docker image, Docker prone. Those ones you are using this application now, this Docker demo application name to be running, to be managing it. So for you to manage all this container, you have to use this Docker demo to manage it. If you want to list all the container you have, you say Docker container list or Docker image list to know how the image you have. So you just consider it like Momoy and the case. So this one, we just put all the source in one place. So anytime you want to spin up, you want to cook Momoy, instead of using the whole pot to cook Momoy, you can just bring up a container, put your Momoy source inside, which is the image, and close it. So each Momoy pot will be running. So you will not have so many portion of small Momoy running. You understand? So I'm just trying to bring it to your understanding. That's why I'm using all this analogy. Hope you understand.
Yes. Thank you.
So I think we'll stop here. Or should I go a little deeper? Let me go a little deeper. Judith, can you hear me? Judith, are you here? Judith is not in class.
She was in class earlier.
Yes. Okay. Okay. We have, but Moses, you hope you're able to get it, right?
Yes.
Hey,
Thank you so much.
Catch it.
Yeah, I will go back. I can start to understand. Yes.
Tomorrow we are doing.
Okay. No, I won't carry back there. Oh, I'll take close.
Okay, now let's go a little deeper. Why will somebody decide to use Docker container instead of installing the application inside? The reason is because if you install a normal application inside an operating system, there are so many things you need to carry. That application must carry. Have you tried to install CorelDRAW recently or Microsoft or any application? You see that for you to run an application, it must come with a drive or if it's either a drive or a CD, right? For example, to install Microsoft, to install any application, let's say Word document, you will have like 3 gig. 3 gig. The hard drive, the system, the disk will be 3 gig. So maybe I want to install, let's say I want to install a graphics application inside, let's say for Photoshop now. You're going to get a hard drive, a flash drive of 3 gig. You will now run it on your system. Your system will recognize if you start installing. It will install not just the Photoshop that you want to install or the application you want to install. It will install everything required for that application to run. First of all, it will install the kernel that will bridge the operating system. Then secondly, it will install the drivers. Then thirdly, it will install the payloader and other application. Then after that, it will now install the application you want to use. You will now realize that the application you want to use is just small. But because for this application to run, it needs all these dependents. So that is why if you want to install 5 applications, all the applications are coming in this size. Before, what will happen to your memory? Your memory will get filled up in time, right? Because you are putting so many
loads to be on it, and
but the application, which is also known as the image, is very small. But because for the image to run, you need all this underlying. So let's assume the image here is just maybe 200 megabytes or 200. Now, because of 200 megabytes, you have, see how many memory. So what Docker does, Docker, if you are running a Docker for any operating system, Docker is operating system dependent, right? So if you are running a Linux operating system, you're going to run a Linux Docker on your system. So what Docker help you to do is this. All these dependents that all Linux application will need, it will install it here. It will be in the demo. So any application you want to just install, so what you will just be picking, you will just be picking the main image and be wrapping it with little image. You understand? Maybe now if I want to install graphics now, what you will do, let me reduce the size to be small. Oh, okay. For example, I want to install CorelDRAW. So instead of installing, loading 300 gig, 3 gig, we just pick only this one. And the little kernel, the little image of Linux, so that they can talk to the Linux operating system. So if we drag the little image of the application and the image of, so at the end of the day, maybe the image will be like 50. The application will be like 200. What do you have now? You now have 250. So instead of carrying 3 gig, you just carry only 250 and run it. Because the things, all that things that you have here is already running, because Docker will drag all this demo, all the payloader, everything you require for all application that is Linux. So you see, at the end of the day, you just be using small image. That's why you can have like 300 containers running, but they will be running under this. So you can see now, you save cost. You provide availability,
space too,
and becomes agile. That is the reason why people are using Docker. So it's not because they want to be learning new technology, because they are trying to save cost. They want the system, to be open.
So how many images can you build in a container? What's your maximum amount of?
The size of the system now, the size of the memory, because the container is actually using the memory that's available in the VM. So it depends on the size of that image you are building and the available disk space available. So you look at the disk space and so as far as the disk space is available, you keep pouring in. And you know, I told you, it's not only the disk space. You know, every container here has almost all the requirements, all the parameters and the characteristics of the VM, including the network,
storage, the network, the compute.
So you cannot use one port to build 2 Docker files. You cannot use one name to build because it's safe in one memory. The 2 content. If you have port 80 already used here, if you want to build another Docker, you cannot build in port 80. So it uses both, it shares the network, it shares everything. So if everything is completely overused, used fully, you will no longer be able to build. So as far as there's more space for your application, there is more memory, there's more compute power to build.
Wow.
So to manage this container, so that in case one goes off, another one comes in, and there's an issue, that is called orchestration. So it's called orchestration. So when I talk about orchestration, so today we have talked about virtualization,
Dockerization,
and orchestration. Containerization and orchestration. So to next class, we are going to practice, we already practiced this, right? But we're just going to run a little practice, run practice on this. We're going to emphasize on this and this. Then from there, we'll look into AWS infrastructure more and more and more. And that's what we're going to be doing till we round up. We're putting an application in a VM, put application in Docker, put application in Kubernetes, like that, how to make it available, how to make it easy. From there, and complete our class. And you guys will be done.
Okay.
Then you become a DevOps engineer.
We are going to treat Rosa DevOps too, right?
Yeah?
We are going to treat Rosa DevOps too, right?
Well, I'm going to just I'll explain it to you, but we not do everything.
Yeah. I understand. I'm just being curious. I think I'll have to study about it more.
Immediately we finish this orchestration, you'll be able to do this. Because everything is what I just did now, I just break everything for you now, right? Like I give you documentation, it's just normal install. Rosa is just a normal application now, just like Microsoft Word.
Okay.
Install this, put application from here into this place. That's all.
Does it require having to put probably a YAML file or an ARM template? More like the way we do for Azure or AWS.
A YAML file mostly is used to configure Kubernetes engine, right?
Yeah.
When you are building a Rosa, from what I've studied, Rosa automatically, it also have its own YAML file yet. Yes, it also have its own operating system, its own what I call package management. Its own package management. Is that mean? So you can also configure the YAML file. It has its own YAML file, but they are trying their best that you will not have the Kubernetes layer of the infrastructure. You'll be talking to the Rosa itself, while the Rosa will be managing other aspects for you, including your infrastructure. It's a very interesting thing. Can read about it.
Yeah, I will. In fact, this particular topic, I have plenty of questions.
No worries. Enough the idea we did here, and the more you do, the better for us. I think we can stop recording here, right?
Yeah.